Let's work through an example problem where we have a cart on a ramp and some extra forces acting on it. So right here I'm going to have a 5 Newton force acting up this ramp, and let's say the mass of my cart is 2 kilograms, and I want to know, oh, and one more thing, there's actually friction here, and the coefficient of friction is 0.15, and remember that's a unitless ratio. Okay? So coefficient of friction is 0.15, there's a tension acting up the incline, 5 newtons, there's mass on the cart there. Let me set up my frame of reference. Generally we choose x and y to be positive, and parallel and perpendicular to my ramp. So I have that. Now I want to know, find the acceleration of the cart. I want to know what the acceleration of the cart is. Well, this is actually kind of a hard question to answer, because if I start labeling all my forces that are acting on here, gravity of course pulls straight down, so this is the force due to gravity. The normal force is exerted by the surface on the cart perpendicular to the surface, so here's my normal force. Now, if these are my x and y directions, then gravity actually pulls in x and in y, so I need my components, so here's FGY, and then FGX, parallel to the ramp. And remember, if this angle I know, and let's say this angle is 35 degrees, and so that means this angle is also 35 degrees. So I know these things. Now I want to know what's the acceleration of the cart. But I know there's friction. Now what I know about friction is it always acts to oppose motion. Well, I don't know which way this cart's going to go, because I know I have 5 newtons up the ramp and I have some unknown force down the ramp. So I have to figure that out before I can figure out which way friction's going to go. So let's take a look at finding this force. I want FGX. Well, that's the side opposite 35. I know FG is equal to mg, which is 2 times 9.8, which is 19.6 newtons. So I know I have this 19.6 newtons here, and I want to know this side of the triangle. Well, that's opposite that angle, so I have 19.6, the hypotenuse, times the sine of 35. And 19.6 times the sine of 35 is 11.24 newtons. So that tells me that this force down here is 11.24. Now remember, this force actually isn't acting right here. It's acting on the cart along the ramp this way, 11.24. Okay, that's the force due to gravity in the x direction. Then which way is friction? Well, since friction acts to oppose motion and the bigger force is trying to make it go down the ramp, then friction must be acting against that, so I have my frictional force Fk here. Now the problem here is to find the acceleration of the cart, so now that I know where all my forces go, I should be able to do that. Newton's second law says net force equals mass times acceleration, and since this is accelerating only in the x direction, only along the incline, then I'm only going to worry about net force in the x direction. So, in the x direction I have 5 newtons acting up the ramp, plus kinetic friction acting up the ramp, minus the force due to gravity, which we just calculated to be 11.24 newtons, down the ramp, is equal to mass, the 2 kilograms, times its acceleration, which is what I'm trying to find. So I have all this information and I want to get acceleration. Well, I need to know a little bit more about my kinetic frictional force. So there's another relationship I know for kinetic friction. Kinetic friction equals the normal force times the coefficient of kinetic friction. Well, I don't know the normal force, but I have enough information to get it, because in the y direction, the net force is 0 because it doesn't accelerate off of the incline. So now I'm going to go net force in y, and if I look at my picture, I have the normal force acting up and FGY acting down, so normal force minus the force due to gravity in the y direction equals 0. So then the normal force is equal to the force due to gravity in y. Well, that's mg, 19.6, times the cosine of 35. And the reason it's the cosine is because, remember, y is adjacent to that angle. So when I do 19.6 cosine 35, I get 16 newtons. So I know that the normal force is actually 16 newtons because it's equal and opposite of the gravity force. I'm just worried about magnitude. So I can take 16 times my coefficient of kinetic friction, which was 0.15. 16 times 0.15 gets me my kinetic frictional force, which is 2.4 newtons. So now I can replace everything in this equation with what I know. 5 newtons plus 2.4 newtons, and those are in the same direction, so I should be adding those up, right? Tension and kinetic friction, minus 11.24 newtons equals 2a. So 5 plus 2.4 minus 11.24 is negative 3.84, and then 2a. So if I divide both sides by 2, I get the acceleration is actually negative 1.92 meters per second. That means the cart is accelerating down the negative 1.92 meters per second. That means the cart is actually accelerating down the incline, and so even though this force is pulling it up, it's not big enough to actually keep it moving up. It'll accelerate down the ramp, so it'll get faster down the incline. So the trick to doing any of these problems is to make sure you have a free body diagram that shows all your forces and you label everything well, and then to go through and find the relationships you know.